Okay, so today we're going to be talking about the formation of ADP from ATP. And no, I'm not talking about toilet paper. So right here in front of me, we have the two molecules ATP and ADP. ATP stands for adenosine triphosphate and ADP stands for adenosine diphosphate. And it's important to know that that's what their names are because it's clearly seen in the structure. So in ATP, we have three phosphates connected to a ribose, connected to an adenosine. And then in ADP, we have two phosphates connected to a ribose, connected to an adenosine. And so if we're looking at the ATP molecule here, the most important features are on these three phosphates because these are the reactive sites in the hydrolysis reaction. Particularly the anhydrous oxygens, which are right here and right here, that connect the phosphates, those are very strong and unstable. So what happens is when the hydrolysis reaction occurs, those are the bonds that break to create the ADP and give off the energy, which is what makes this reaction so important in the body. In fact, this reaction here gives off a whopping 37 kilojoules per mole, which in terms of organic chemistry is a lot of energy per mole to be giving off. And it's important because this energy is then used by other cells in your body. And so as we go into the mechanism, it's important to note that, or to pay attention to these sites because these are the reactive sites. And I know what you're thinking. You see 5 bonds around this phosphorus, but it's okay because this double bond is equally distributed via resonance around this phosphorus, and so it's actually not a pentavalent phosphorus. However, you will get to see a pentavalent intermediate in the future.
Hello! So now that you've heard more about what ADP is, we can talk about how it's produced. So first things first, here's your ATP molecule. Now I know Eric touched up on the components of this. So this reaction is a spontaneous reaction, but it happens very slowly until an enzyme lowers the activation and energy of our reaction. So that enzyme is called ADPase. And what it does is it basically neutralizes the negative ions on your oxygen atoms, and then also turns your water into a hydroxide, which makes it more nucleophilic. And because because your oxygen atoms have 2 lone pairs, you can have a nucleophilic tag on your phosphorus. So what this does is creates a bond between your phosphorus and your oxygen atoms. Okay, so the only reason that your water molecule can form a bond with your phosphate group is because your ADPase takes your H away from your water molecule and leaves you with hydroxide, which is very nucleophilic, which means that the reaction can proceed. Now this is a forward reaction, which means the reverse reaction does not occur because the activation energy is too high for it to be able to occur. So after your hydroxide forms a bond with your phosphorus, you get a pentavalent phosphate group. Now, this is not what we like to see. So what happens is this bond, so these electrons go to your oxygen on the rest of your ATP molecule. So what that gives you is a really, really, really good leaving group. And what do leaving groups do? They leave. So what you're left with is two phosphate groups, which gives you ADP. Is the reason this reaction is so incredibly important is because it produces energy, and not just small amounts of energy. It produces about 37 kilojoules per mole of energy, which may not seem like a lot, but it is. Sam will talk about it later. So your products then will be your phosphate group, ADP, and energy.
Okay, so the reason why we're talking about ATP is because it's one of the most important processes in your body because it's what your body thrives on to move like we do every single day. when we do exercises, or even when we just walk or lift small things like books or our pencils or whatever. So the body runs on ATP, which is why it needs a lot of it and why a lot of it needs to be formed. But since we do certain activities that are slower or take less energy than others, it has to form it in many different ways, because ATP itself is a very, very high energy molecule. We need very, very, very high energy systems in order to form it. So the phosphagen system is what we use when we're doing very small activities. So this includes maybe like a few second activities, like just sprinting really quickly, or like very large bursts of energy when you're like lifting something really heavy really quickly. The glycogen-lactic acid system is what we use when we do things that are more than a few seconds. So like when Professor Wenhold said that he's gonna take a quiz at the end of class, and a lot of people are running in at the last second to take their quiz even though they're not supposed to, that's when they use the glycogen-lactic acid system, because it's several more seconds than what's for normally. So the last system that I'm going to talk about is the aerobic respiration system. And basically this is what we use when we do very long-term activities. So for a marathon runner, they would use the aerobic respiration system. The reason why the aerobic respiration system comes into play is because it makes ATP very slowly, which means that we can use ATP for a long period of time, and which is why our energy stays up and going for a long period of time and allows a marathon runner to run for as long as they need to finish their race. So these three systems are the main reason why ATP
So as Sam
is
explained,
formed.
muscle contraction requires energy from ATP hydrolysis. Here you can see ATP binding to the globular heads of myosin. Then the chemical energy stored in the third phosphate group's bond to ATP is released as kinetic energy to move the myosin head and return it to a ready position to attach to actin again. This process happens over and over again to give us energy to contract our muscles. So there are many ways that you can increase the amount of ATP hydrolysis going on in your body. One of the ways is to consume a compound called L-carnitine. It's commonly found in meats and other types of protein, but it's also one of the main ingredients in Monster Energy Drink's Energy Blend. The reason they use it in there is because it increases the amount of ATP hydrolysis in your system, which is why if you ever drink a Monster Energy drink, you'll feel an immediate boost similar to that of coffee.
Oh.
Thanks, ATP hydrolysis.
So to summarize the main points, we have the adiapase that turns the water into the hydroxide, which allows this whole reaction to occur. We have the hydroxide undergoing nucleophilic attack on the phosphate, and then the electrons moving over, which gives us our two products, three actually, our ADP, our phosphate, but the most important product is our energy. And this energy is used in all different types of actions in the body. Anything that involves your muscles contracting or moving will undergo this process. The phosphagen system, which is the fast twitch system and occurs when you are trying to do something in a very quick way. And then the second is the glycogen-lactic acid, and this is where you're trying to do something in a more moderate way, like jogging or moderate intensity activities. And Lastly, the aerobic respiration, which is walking or anything that is very low intensity, that your body doesn't need the energy for your muscles to contract.
So if you ever feel like you don't have enough energy to go to Orgo lecture,
Drink some L-carnitine.
And cheers to ATP.